Good afternoon, everybody. How are you today? Today we would like to represent to our project proposal presentation. The project we have here is tracking of the driver eye movement, which is we try to develop a system and a method to track the eye of the driver when they are driving. So the team name, the team we have here, our team name is a Creative Artistic Robotic System, which is the shortcut is a C.A.R.S. I would like to introduce our team leader, also a spokesperson, Josh White, and our analyst, and our recorder is C.A.R.S. by day, and our pessimist, Clarence Hauser. And me, myself, is an optimist of the team, T-Lane. And we would like to go to, and our customer and advisor is a Dr. Abdullah Homaifar. And to talk about more about the project, we would like to go to the next slide, and please, Josh.
So just going to talk to you about the need for this technology. Accidents, automobile accidents are the 5th leading cause of death here in America. They account for roughly 34,080 fatalities every year. And 80% of these automobile accidents are due to distracted drivers, that being drivers who are texting, drivers who are talking on the phone, who are eating or yelling at their kids, just not paying attention in general. And 100,000 accidents, automobile accidents, occur every year due to sleep-deprived drivers. So there's a really big need for this, and if we can somehow cut down on the amount of distracted drivers, we can cut down on the amount of accidents and the amount of fatalities here in the United States. So our plan is to design a eye tracking system to monitor the SimVista driving simulator we have here, and this will be used to predict a driver's distraction level based on their eye movements, where they're looking at, are they looking down at the ground, are they looking away, that sort of thing. And we're going to log and monitor each of these warnings whenever a driver takes his eyes off the road. That will be used to help our pre-crash algorithm team to predict and model driver behavior. And our system should be intelligent, accurate, and non-invasive to the driver, because we don't want to do anything to make it harder for the driver than it already is. A little bit of background on this type of technology. C.A.R.S. is going to talk about a relevant technical paper.
So we had the paper on the Samsung Galaxy devices that use eye tracking software, and they use the camera and things in the tablets and the phones that actually monitor your eyes to see if you're looking at the tablet or not. If you're looking away, then it'll turn off the screen, or if you're watching a video and you look away, then it pauses the video automatically for you. And it also used the photo sensor to adjust the amount of light coming in. If you're outside or something and it's sunny, then it can adjust that also, and it still detect your eyes and stuff based off of those readings that you get. So we were thinking to incorporate those sensors in our design, so that if we're driving and it's sunny or something, or that it's nighttime, then we can adjust how we can see the driver's eyes based off of that, those parameters, different parameters that we need.
And Ty, can you talk about the patent that we found?
Yes, the patent we found is a patent. This patent is you see the patent number on the screen. It's a US 6927694. It's published in the United States. This one provides the primary objective of the patent is to provide a system method to monitor the driver eyes to detect that the driver active or lack of sleep. So when the driver lacking of sleep, the system will track and alert the driver, and also the second objective of the pattern is also tracking the driver, the rotation of the driver head, so that can track it and prevent alertness of the driver in advance. And also this system also can be used in the real time to prevent an accident.
And a commercial product out there that's relevant to our topic right now is the Smart Eye Pro eye tracking technology that incorporates up to eight different cameras on your driving simulator, so it can tell where you're looking at on the screen, where your eyes are being pointed towards. Operates between 60 hertz and 120 hertz. And the difference in frequency is the difference in delay in real time. So at 60 hertz, you have a 50 millisecond delay, and compared to 120 hertz, we have 25 millisecond delay. So that's something we're going to look into and decide which frequency would work best for us, as well as where we would position our cameras and our sensors when we develop ours. And the next part of our slide, marketing requirements. You want to talk about that, Clarence?
As far as our marketing requirements go, we want something built that could be intelligent, accurate, something more logical for them to know how to use, reliable, and controllable. As far as the intelligent goes, we want it so that it'd be smart enough for them, it would be easy for them to use, but smart enough to actually track them accurately. Controllable, we want them to be in control of it as much as possible.
Yeah, to add on to what Clarence said, we want it to only track and log data for when the simulator is in motion. So we're not concerned when it's stopped at a stoplight or whether it's in park or something like that. So, and another thing, we don't want to, like I said earlier, we don't want to restrict driver movement. So we want it to be logical. We want our warnings that we send out to the driver to not be too disruptive, that they lose control of the car or anything like that. We also want it to be very reliable and to work in different types of driving situations. So here are our engineering specifications, things that we want our system to do in comparison to our marketing requirements. So for intelligence, we have the system
Can
should
you zoom this?
zoom in.
Yes. Okay.
So
Still,
it's still
That's fine.
so
You can go ahead and talk, but somebody else can
okay.
zoom it a little bit more.
Okay, so as part of one of our engineering requirements for it being intelligent is it should alert the system that the driver is distracted after roughly 1.5 seconds. So if he's looking away for 1.5 seconds, we figured that's like a standard amount of time for a driver to check their blind spot, which we qualify as normal driving behavior. So anything longer than that, the system should track as distracted driving. As far as accuracy, it should work on different drivers of different heights and sizes. And logical, any alert sounds we have should not exceed 45 decibels, because justification for that was that we don't want to cause any alarm or panic for the driver. This is our level function block diagram, which is just a broad overview of what our system does. You guys want to chime in here about our inputs and our outputs?
yeah, so we wanted to add different inputs, and also, we talked about having multiple sensors for the right eye, the left eye, monitoring different things, and included with that would be like different parameters for your eyes, like your pupils, your what's the word for your
Dilation,
like the
iris.
yeah, the iris, and how to determine if you're blinking or if you're actually asleep, if you're wearing glasses or something, different inputs, and also like driver preferences and vehicle activity. Driver preferences, we can change like sensitivity and with the vehicle activity, we were gonna add like a accelerometer and things to know if the car is moving or not. Then, because if the car is not moving, then there's no reason to alert the driver.
And these are our inputs in our power, 12 volts DC. This continues our function block diagram here, our right eye movement, left eye movement, which C.A.R.S was talking about. So in conclusion,
Basically, we just want to determine if the driver has become distracted based off eye movements, as well as knowing if they're drowsy or sleepy, because those are the two leading things is distraction and drowsiness when it comes to accidents in our world. So we would like to create this to better help our drivers from being distracted and knowing when they need to pull over because they're too drowsy to continue driving.
and we want to log all these driver distractions into a database, some sort of software where we can report back to our pre-crash team as to this is to model driver behavior and driver distraction behavior. And these are some of the references we found as we were researching this project. And any questions?
Okay. Okay, any question from you? Talk louder.
Do you use a microcontroller on Android? Arduino?
Arduino board?
Yeah.
Yes.
Yeah.
That is, we didn't talk about that. Arduino board, we're going to use that to,
We can use the Arduino board. You can connect the sensors to it, and it actually Arduino has like different libraries for the LCD screen. So the readings that we take from the camera, we can in our program, like if we write the code for it, we can use those readings from the different sensors, right? For the photo sensor, it detects the amount of light, so we could take that and adjust the contrast for the readings that we're getting from the camera.
So that means you use Arduino to connect the sensor data.
Yeah, so we can connect that one to the Arduino board and
send out our warnings through outputs from
Yeah.
there.
so it would run it can run the code on here.
Alright, so you're talking about being able to alert the driver on the distraction, right?
Right.
Yeah, basically I just want to ask, in what criteria would you use to assume in this case the driver is distracted? Is it that if I'm looking straight forward onto the eye tracker you're going to have, or probably I turn to this direction for 5 minutes and I'm distracted, or
Right,
what
we're
are
going
going to be
to,
these criteria?
basically the thought process is if you're looking straight forward,
Okay.
we're going to make that assumption that you're looking at the road and you're not distracted. But if you turn away from the road for longer than that 1 second, we're going to assume that you're engaging in inattentive behavior, and that way we'll be able to tell you how long you looked over there, what you were looking at, and then be able to report back to and log how long you looked there, where you're looking at, and just log that into our database for warnings. So if you're looking down or away, like I said, for longer than that 1 second, then we're just
How
going
did
to.
you come by the 1 second? Is it something standard?
Like I said,
Just an
I
assumption?
kind of just use the blind spot when the driver's checking their blind spot really quick. That usually only takes a second, second and a half maybe. That's something that could be adjusted as we go further, but that we just felt that was normal driver behavior to check the blind spot real quick, and we didn't want to get those warnings confused with our real warnings.
We have 2 more minutes, but let me ask you a question. How do you know that I'm not gazing?
That you're not gazing.
Yeah,
Like daydreaming?
because I'm looking straight. I'm looking at Mr. T, right? How do you know that, I'm looking forward doesn't mean anything that I am paying attention to the road?
But we could possibly add something like a blink type detection. We know if you haven't blinked.
Say what?
If you haven't blinked, like a blink
Blink,
detection.
yeah, that is the question,
So
yes.
if you haven't blinked within like 30 seconds, we're going to assume that you're still gazing in to a direction. If you gaze for too long, you can tell you may distract because your vision is possibly going forward.
Good. Now, you mentioned about marketing requirement. What do you mean by marketing requirement? To me, is marketing requirement is like as if you want to sell something. What does that mean by marketing requirement here?
The marketing requirement is basically what we think it should have based on customer customer needs, based off the need based of it. So we gotta determine what we think it should have or how it should be made.
Now, what about cost? I may, remember that. Okay, marketing requirement. Mr. T can maybe he dreams of so many things, but so what? Is he willing to pay for it? What about the cost? How much this is going to cost?
We've researched a couple possibilities, and they have been pretty expensive so far. So we're still working on the cost analysis portion.
Well, how much was it?
It was something like $21,000 for the ASL head or motion tracking.
The one that she sent that to you?
Yeah,
21,000.
yeah, I got a quote today.
Okay.
Yeah,
Wow.
that was pretty outrageous. But so yeah, that's obviously way too expensive.
You said the one that was fixed on the
I checked the desktop and the glasses. The desktop was $24,000. I got some quotes I was gonna send you guys, but yeah, the desktop was like 24, and then the glasses were a little more because they're, I guess you can walk around.
If that is like that, maybe we can research a little more about those sensors for the Samsung Galaxy that you mentioned.
Right.
That it also, I guess, takes eye movement because when you look away from the, for example, the screen, it stops what it's doing. So maybe you can research a little more on those. Those are probably not as expensive because they're affordable.
That's pretty outrageous.
Your time, sir.
Okay.
Okay. So this demo is going to explain the use of the leftover part. Our leftover part that we got was the photo sensor from the senior design lab, and this will detect the light, the amount of light going in, and if we can take this sensor along with the camera and the other sensors, and we can hook them to the Arduino microcontroller, and from that microcontroller we can determine from the readings that we got from the sensors if the driver is distracted or not.
So yeah, I'll go ahead and start the program. You guys will So this is our DC analysis. As you see, when light hits it, the voltage increases to 2 volts, and when we close off all light, the voltage goes down to 0 volts, so it's detecting light. And then if we go to our AC,
the other window. So the reason we did the AC and DC is because in the car we have the alternator that is doing the AC current, and but from the battery it should be a DC source. But just in case, we can do 2 different ones to show.
I have a question here. Why you use DC and AC? Why you use DC and AC?
Because if the car, since it's running off the alternator, whenever it's running off the alternator, and the alternator is producing AC current. So when we have that, we have to take into account that from that AC current we have to change it to DC first before we can use that power.
So that means you are going to design the power module.
Well, I think if we need to use that power source, but I was thinking the battery in the car is hooked directly to the alternator, so I don't think necessary, but it's good to take into account just in case.
It's not that much important to care to take too much consideration about the power.
Yeah.
Just assume you have
Okay.
some power source and just
I think the other reason was because remember in the sensor we were talking about like whether they use 60 hertz or 120 hertz for the time delay. I think that's the other reason we can use the AC.
that is the rate at which we collect data, not the rate at which
Okay.
power is provided.
Okay. So, yeah.
And we're
Very important. Thank you.